Hey, calculus. All right, finally, 29 and 30, and we're good to go on to some easier stuff. All right, so number 29. Y equals the inverse cosecant of the secant of x. How about from 0 to 2 pi? X here. All right. We have inverse cosecant. We're going to come over, do our usual. Y equals inverse cosecant of x, which means cosecant of y is equal to x, which when we differentiate the derivative of cosecant is negative cosecant y cotangent y, and dy dx equals 1, which means that derivative with respect to x is equal to 1 over, by division, cosecant y cotangent y. Cosecant y is easy enough to change into x. And cotangent of y here. Cotangent of y, in relationship to cosecant, have our usual bit where we have the 1 plus the cotangent squared of x equals the cosecant squared of x. We'll solve out for cotangent. Well, we'll do this in y to make the relationship more visible. So that means that the cotangent of y, I'm going to subtract 1, take the square root of both sides. Cosecant squared of y minus 1. And that'll do fine because we already know the cosecant. So to move the negative 1 over, keep our x. Cotangent of y is equal to the square root of cosecant squared y. Cosecant is x, so that'll just be x squared minus 1. So that is our, of course we have dy or dx afterwards. So we'll apply this here. So we take our derivative of y with respect to x. We'll have, so this is our x. So that x is going to show up twice here. So we'll have 1 over, that'll be secant x times the square root of secant squared minus 1. So that's this in there. I forgot my negative. And times the derivative by chain rule. Derivative of secant is secant tangent. Which is convenient because those two secants will cancel. Secant squared minus 1, I can't remember if that's a relationship or not. So I'll write down the relationship as I know it. I know that 1 plus tangent squared of x equals secant squared of x, which is one of our Pythagorean identities. And yes, secant squared minus 1, we subtract 1 from both sides, just equals tangent squared. So from here, dy dx equals negative 1 all over. So that's gone away. That square root is still here. Secant squared minus 1 is equal to tangent squared of x. And then still times tangent of x. Might come out very nicely. Square root and tangent squared go. Tangent and tangent go. So dy dx was negative 1. That'll work for us. Rounding off number 30. is equal to 1 plus the sine of theta over 1 minus cosine of theta. It's quantity squared. So there's two things at work here. We have a quotient, which we can just use quotient rule, and we have power, so that'll be power chain rule. So we're talking about R equals 2 times 1 plus sine theta, or 1 minus cosine theta. That would all be in parentheses to the 1, because the 2 dropping down, then times the derivative of this. Now we need the derivative of these two. So it's bottom to top, top to bottom. Derivative of the bottom. Derivative of cosine is negative sine. Oh, sorry, bottom d top. So 1 minus cosine theta. That's bottom d top. Derivative of sine is cosine. Minus top d bottom. Top d bottom. Sine theta. That's the top. Derivative of the bottom. Derivative of cosine is negative sine, but negative sine is just going to be sine. All over the bottom squared. 1 minus cosine, 1 to the squared. Alright, let's clean up a bit. This is 1 minus cosine theta, 1 minus cosine theta squared. So we can put this all over a big fraction. We've got 2 on the top. 1 minus cosine cubed theta. That's the bottom multiplied. Top multiplied out. Let's see what we get. We get 1 plus sine of theta. These two multiplies, that'll be cosine theta minus cosine squared theta. And minus, make this a little longer, minus sine theta plus sine squared theta. All right, so we still have 2 multiplied by that times all this. Let's see. Right, so the 2 was outside, 1 plus sine theta was here, and then these 2 multiplied just came in here. We've got negative cosine theta and a negative sine theta, so that should just go to 1. Yeah, we can do that inside here. So we do our trig practice. Trig is good. 1 minus cosine cubed of theta. And we'll keep this for the time being. 2 times 1 plus the sine of theta. And times. Let's take a look at this here. So this is going to be cosine minus cosine squared. Let's get rid of this parenthesis. That's minus sine and minus sine squared. Alright. And we're going to take this minus cosine squared and minus sine squared. I'm going to change that to minus sine squared theta plus cosine squared theta. That's just minus 1. So we get rid of this and this and make a minus 1. So that'll be cosine theta minus sine theta minus 1. And I don't see that reducing any. May well. I think that'll do just fine. Alright, so now on to hopefully what are some of the easier problems from the middle of the chapter. There's a lot of differentiation. Differentiation forms the basis of everything we do for the rest of the course. So it would be nice to have a good solid foundation of it. We need to find the values of x for which the function is differentiable. y equals natural log of x squared. And we'll take the derivative dy dx. Remember, we could make this 2 natural log of x. Either one would work just fine. So it's 1 over x squared times the derivative of x squared, which would be 2x, a chain rule. That's just going to equal 2 over x. The values for which this is differentiable are the values for which this function is defined, which is every number but 0. So our answer is x not equal to 0. Value for which y equals sine x minus x cosine x. What values is that differentiable? Well, we'll go ahead and differentiate it. Derivative of sine is cosine. We have product rule. This is minus and then in quantity. First times the derivative of the second. Plus the second times the derivative of the first. We just distribute out the negative a bit. Wind up with let's see, so that'll be cosine x minus that minus cosine x. So this cosine minus this cosine. So we just have positive x sine of x. And that is differentiable for all real x. Because this is defined everywhere. We'll save 33 for the next video.